So welcome everyone. My name is Joshua Richards, part of the leadership team in the UK OSINT Community and founder of OSINT Praxis. This week's video, we'll be going through last week's Capture the Flag. I suppose it's this week's Capture the Flag, which is Operation Serpiente. And it's just 5 challenges where the aim is to use different Python scripts and functionality to be able to kind of analyze large data sets to help you get an answer much more quickly than if you were to do these things manually. So let's jump straight into it. So first we have Operation Horizon. And with this one, it says, word around the office is that you know your way around a Python script. Because of that, the boss just dumped a massive social media scrape on your desk. Doing this manually would take weeks, but we need answers today. So if you download the linked file here, socialmediascrape.jsonl, that is then going to give you this file that we have here. So it's 20,000 lines. If I go down the side here, you can see we have 20,000 lines of this crazy JSON code. And usually you might be familiar with JSON. This file format of JSONL is like JSON lines. So every line is a new bit of the JSON code. So if I copy one of these and just bring it into this JSON beautifier just so that you can have a look at it, this is kind of what it's doing. So we get one massive line, which is a bit hard to really understand. But when you beautify that, you can see what it's actually doing, where every line is a new post. And in that, we get a post ID, an author ID, like the user ID for who actually posted the main primary post, the username of the author, the content of the post, and then all of the comments. And you can see it's not the same here where it's like, you have content and then the content is here. But in this one, we have comments and then all of the comments are individually under that, where each comment has an ID, a user ID for who posted that comment, and then the actual comment text itself. So what we're looking for is actually these kinds of ones here, where the text is specifically saying Project Horizon. Nothing else, literally just that on its own. So this is an example of one we're trying to find, and this particular user is user 1102. But it tells us in the challenge that we're specifically looking for what user commented that on the posts from 5 distinct authors. So now this is one where user 1102 has posted on the post of Blake 42. So that is now one distinct author. We need to find who has done this with 5 of those. Obviously, if you were to do this with 20,000 lines, it's just not doable. It would take so long to do, and it's a bit of a waste of time. So that's where we can use Python instead for this. So I just have all of this open in PyCharm, but you can use lots of different things for this. And basically, I've just got this one op Serpiente folder with all of the solution scripts and all of the data from the different challenges. For example, this one, socialmediascrape.jsonl. And so if I open challenge number 1, this is an example of a script that can solve this challenge. And you'll know if you've done any Python and if you start to learn it a bit, you'll see there's unlimited versions of what you could do. You could probably make something a bit shorter than this and it would work fine. You could make a much more complicated and solid script than this as well that would work a lot better. So it really is up to you. But this is one example of something that works. And what I will say while I remember here, that when I was doing this challenge, because I wanted to make these big, huge data sets that wouldn't be able to be done manually, I used a Python script to generate the data. And sometimes that has come up with some issues. And, certain people manage to identify those issues, like Uzea. where if you read his write-up, I definitely recommend you go check out his write-up, because he's put loads of different solutions for each of the challenges, which are really cool to learn from, in addition to the Python script versions. And as he mentions, he found out that there's not really just one answer to this challenge. Because I wanted to add in decoys, where there's actually loads of other people who post just that phrase as well, but they were meant to post it like more or less times, not 5, like the answer we're looking for. Unfortunately, the way that that all worked meant that it was kind of left up to like randomization, and ultimately around 74 to 75 other random users also posted that 5 times, like 5 different authors. So technically there's lots of answers. However, the one that people usually found first was that first instance of who posted 5 comments on like the 5 distinct authors first. That was the answer. So extra points if you managed to get that and understand the issues there with the decoys. But okay, so if I run this script, you see here instantly, again, how much time would that take to literally go through manually? I just click it here and instantly we get an answer that the flag is user 1102, because that user 1102 posted that specific phrase on the posts from these 5 distinct authors. And again, he's just the first one to do so. And so if we have a look through the script here, all this is doing is importing a JSON library just so that we're able to work with JSON. Otherwise, our file would basically just be like text and you wouldn't really be able to do as much with it. But because we've imported the JSON library, that allows you to actually treat it as JSON and do some really cool stuff with it. Then we add a tracker dictionary. So it's empty right now, but we'll then be able to add data into this so that we can, do different functionality with it later on. It then prints out some text. So this is kind of irrelevant. It just prints it out into our chat so that we can see what it's doing and make sure that it is working. And then phase 1, read everything and get the final totals. So it's going to open the file. And by the way, I don't think I mentioned at the start, this walkthrough in general won't aim to go so much into detail into like every line of the script and be some crazy Python tutorial. I just want to give an idea of the kind of stuff you can do with Python. And again, showing that sometimes these things can literally process all of this data in seconds or less when doing it manually, and potentially things you are actively doing right now manually that Python could do in literally milliseconds. So I just want to get that across, and then you can always use AI and different online YouTube tutorials to look at specific Python functionality that would be useful for your use cases. Because like I said, there's different scripts that will be able to do different things in different scenarios. So, so it opens up our scrape data file. And what it then does, where it says for, this is going to be a for loop. So it is going to loop through every line of that file. Because like I mentioned, it's not like, a massive JSON file where it spans multiple lines. Every individual line is a new piece of JSON code on its own, independent of one another. So we go through, and the first iteration of the loop is the first post done by Blake47. And so then it loads that JSON into this variable. This is just a variable where that JSON data is now stored. And then we get the author username. So this is an author variable, and we simply set it to the author username from this first post. Again, if you're new to Python, what I'm saying right now might just be very confusing, but definitely go out and watch some YouTube videos on Python, as things like this with the for loops are one of the more like basic functionalities of Python that you'll see yourself using a lot if you do get into Python programming. But again, I don't want to make this like 3-hour long tutorial going into every specific part. But you see here again that we went through earlier where it has the author username. So that is what we're referencing. Author username, Blake47. So here, this is simply setting the author variable to Blake47 because it's getting the value of this entry from that first post. But it's looping through every line. So it's going to go through and do that for every one of those 20,000 lines, and it will do it in less than a second. Then it's going to loop. You see again, like I mentioned, looping. We loop through every line. Now, in every line, we loop through every comment left on that post. So now we have if the comment text is equal to Project Horizon. And this double equal sign means that we're searching for an exact match. We're not looking for if a comment has, like, you see here, let's say this one, like certain score morning read. Let's say at the end of this comment, we had Project Horizon. That still wouldn't match because of this other text in it. We're looking for a very specific match with no other text, literally just Project Horizon, exactly like this one, where the text is only Project Horizon, nothing else. So that's what that double equal signs means there. And so then if, this is an if like conditional statement here, if the comment text is just Project Horizon, then we're going to add the user ID of who left that comment into this user variable. Then we're going to check if that user or user ID is already in our tracker dictionary up here. If it is, if it isn't, then we add it. We add it to the dictionary. If it is already in it, then it just doesn't do anything. And then the author, because again, going back to the actual original purpose of this challenge, is to find that user ID of who's posted on 5 distinct authors. So we need to see now, is this author of the original main post already in the dictionary as one of the distinct authors for this user? Hopefully it's all making sense again. It might be confusing going back and forth through all of this, but again, this is being recorded as well, so it will go on YouTube and you can go back through it. And again, it's more just to get across the kind of basic functionality here, like the if statements, the for loops and stuff like that that you're able to use in your specific scenarios. And so it does all of that. And so now just in this small piece of code here, that goes through every one of the 20,000 lines in less than a second. And it puts all of that data into this dictionary up here, where it will have the user IDs and then the usernames of all of the authors of the main posts. So now that we have that dictionary, you can go through and simply say, for every user in our dictionary up here, if the length of like the authors, so the authors lists of who each user has commented on, if that equals 5, because we're looking for ones who commented on 5 distinct authors, if it does equals 5, then it's going to print out that we have solved the challenge and it will give us the user ID of who that person is. If it isn't 5, then it would just skip it and keep on going through the loop until it finds the first person who does meet that. And again, this is one where there are more answers, unfortunately, but we're just looking here for the first instance, and that is the correct answer. So if I run it again, you see here we get challenge solved, user 1102. He commented on these 5 distinct authors, and so that is the answer. And so I'm going to go put that in here. And there you go. So now moving on to number 2, we have low and slow. The SOC team just handed you 200,000 lines of firewall logs spanning 3 days. A standard spreadsheet will choke on the time analysis required for this, so it's time to script it out. So again, here now in this one, we have a CSV, like a comma separated file, and it has timestamps here, and then IP addresses, which is, over here, and then the action that IP address took. For example, a failed login and a successful login. And what this challenge is asking us to do is specifically, see here, analyze this file and find the single IP address that had exactly 14 failed login attempts, followed immediately by 1 successful login, all occurring within a 3.5 second window. So you have a very specific thing to look for here. And again, it makes it quite difficult to really do that manually. If you just try looking for, let's say we did a Control F and you see here, we're just looking for, all of the times it says login failed. I mean, there's 40,000 of those. You can't just look for that. Even if you could find one where you try to make it find 14 login fails in a row, that also doesn't work because, maybe they're mixed in. You have loads of different IP addresses here. So maybe there's 10 login failures and then a different IP address successfully logs into their own account. And then there's more failed logins from your IP address that you're looking for. So it doesn't mean automatically that they're going to be all attached to one another. So that's where we need to use one of those like rolling kind of windows where, let's go through the script here so you can see. Let's go challenge 2. So if we go through, we're importing CSV, similar to what we did last time with the JSON one. And then we're also importing date and time so that we can do some different mathematical things with that later on to see how much time did elapse between the first login failure and the successful login to make sure it's within that 3.5 second window. We, again, similar to last time, we have our dictionary here because we're going to want to group all of the logs by IP address. For the reason, like I said, where, there's going to be multiple things from the same IP address, but they're not going to be like all attached to another or one another. So we want to group all of them in its own dictionary, and then we can look at all of the actions every specific IP address took much more easily than 200,000 lines all mixed together. So we then open the file. Again, you'll see lots of similarities to last time in the first challenge. So we have it opening the file. We have reader, and it uses that CSV library from up here that we imported to import that kind of file, but do it as a CSV. So it's going to allow us to access the columns where, again, you can see here, we have a timestamp column and then a comma, the IP address, and then a comma. So by actually importing it as a CSV, we'll be able to strip out just the second column, and that's going to give us specifically the IP address. And every line is consistent with that. So it allows us to analyze much more easily. So we skip ahead just so that it goes down to the next line, because we don't want to get the titles. We want just the data parts. So we're skipping down here to line number 2. And then again, we're using our for loops to start looping through every row and every line. And we're getting the timestamp, which is at row 0. We have IP address, row 1, and the action it took, like the login failure or success, at row index 2. So now we can connect the string to the time object. So that's where up here we imported the date and time library. It already is a timestamp, you can see here. But basically, by actually creating a date and time object in Python, that's going to allow it, similar, like I said, with importing it as JSON, importing it as CSV, it allows us to actually do Python functionality with it. It's the same here with the date and time. We can specify how we want it to be formatted with like the year, month, day, hour, minute, second, and all of that. And then we'll be able to do specific functionality with it within Python later on. And so then we go, if the IP address isn't already in our dictionary up here, then you add it in. If it is already in the dictionary, then you're safe to just leave it. It skips past. And again, this is going through every line. So it will look at every IP address. If it's in our dictionary, then it just loops to the next line. If it isn't, it adds it in. So by going through the 200,000 lines, we're adding in every single IP address that exists to this dictionary, but without duplicates. And then we have, for every IP address, we append, basically add in to our dictionary, the date and time and the action the IP address took. So basically, we're then going to have this dictionary where the first entity is an IP address, and then attached to that IP address is a list of date and timestamps and the action it took. So for one IP address, you could then have a list of, 10 different actions, all with their own timestamps and login failure, login success, login failure, and so on for a particular IP address. And we're going to be having that across thousands of different IP addresses here. And so now we're hunting for the 15 attempt pattern. So now that we've got all of that in our dictionary, we then start to do a for loop where we're looking through our dictionary at each IP address. And then we go, if the length of the logs for that particular IP address is more or equal to 15, because obviously if we're looking for a 14 failed logins and 1 successful, it's not going to be an IP address that doesn't even have 15 events, right? If it's only got 13 events, it can't possibly be that because it doesn't have enough of what we're looking for. So it checks here to make sure that that IP address has at least 15 events. And then if it does, we continue on. If this didn't match, if it doesn't have 15, it just skips and loops to the next IP address. So if it does, okay, we do another loop here. And now we're looping through. And this is where it's making that kind of sliding window where Uzziah, in his write-up, like I mentioned, you should go check that out. He explains it really well on the reason for doing this. Because basically, let's say you had our correct IP address that we're looking for, and that did 5 failed attempts and then a successful attempt. But then an hour later, you have 10 or however many. I think that I'm probably messing up the math here, but just say 10 failed attempts again, and then a successful one. That's not going to match because it would find the first attempt, all of the others, including the hour window, and then the successful one. And it just wouldn't match up. So you need this sliding window that basically checks every single one, find the next 15 or the next 14 after it, check if our pattern matches, and then make sure that it's within the 3.5 second window that we're looking for. So it's a bit confusing, but hopefully you'll see a little bit here. In the code, it's a bit confusing as well. There's things like you see here. So the for loop that we've seen, but this one is a bit more confusing where it's working with a range of numbers. And we have here this, which is always confusing to me as well. But it brings an interesting thing that I was speaking about recently as well. This here is the exact kind of thing that I often speak with AI about because it's very confusing to me. And I was speaking with someone recently about the use of AI, like in universities and schools where people are just using them instead of actually learning things. And there's always the debate now where it's like, should AI not be allowed to be used? Or since it's such a big thing in the world now, should they be allowed to use it? Because that's what they're going to do in real life as well. But I think it's interesting where it's still so important to have at least a basic understanding of what you're getting the AI to even do. Because like when I was doing these scripts, I was running different things through AI, checking on like the best way to do things. Like, does this actually work in the most efficient way? Just by pasting in the different scripts, making edits and all of that. And one of the scripts that the AI gave me for these challenges was, on the first one, I think it was, where you had to find the 5 distinct authors. And it was going through a for loop and basically saying, as soon as a particular user ID gets to 5 distinct authors, just cut the script and say, we found a successful result. That's what it gave me. And it told me that this is a good script. This is perfect for your solution. But I just read it. Like, I looked at the script myself and instantly I could tell it, like, no, you're literally looping through here, looking for when it gets to 5 and instantly cutting it out. But what if that same user actually commented 7 times on like different authors, like 7 distinct authors? You won't know that because you're cutting it as soon as they get to 5. And so then as soon as I told it that, it said, yeah, you're 100% right. My script was flawed. So imagine how many people are out there blindly listening to AI, giving it incorrect or not the most effective things, and they're going out and using those without truly understanding it. But even though I'm using AI to help me create things, I have a good enough understanding of what it's doing that I can call it out on its mistakes and actually work with it to make sure it's giving me the most effective things. So yeah, that's just something I was speaking with people about recently, which I thought was interesting, where I definitely recommend getting a decent understanding of Python, even if you're then using AI to help you with the actual execution and creating scripts. So there's this. We're then going to extract just the actions from our current window. So again, we're not going to just pull out like every action for that particular IP address. We're going to pick an action or like a time frame in that particular IP address. And then look exactly for the 14 fails and then the 1 success. So it's going to say if statement, we use those a lot. If the actions count login failed, so it's counting the amount of times you have a login failed. If that equals 14 and the action 15, this is like indexing. So it starts off at index 0, then 1, then 2. So index 14 here is technically the 15th thing. The 15th action, if that one is a login success, then it's going to be true and move on to this next indented code. If not, it will just move on and go to the next loop. So if this is true, then we have a calculation for the exact time difference. So the time taken in this window, it works out the total seconds. If the time taken is less than the 3.5 seconds, then it tells us that we've solved the challenge and it gives us that particular IP address. If it isn't within that time frame, then obviously it will throw it out and just move on to the next one. So this one is, very complicated to explain. It's got lots of these more complicated kind of functionality within Python. But again, this is something you're able to give to AI and have that explained to you. Even though it's not always perfect, it will be very good at explaining to you line by line what each thing is doing and explaining, again, the importance of having the sliding window here as opposed to just very basic loops and how those would actually fail to get this answer. But so now if I run this script, there you go. We instantly, within basically a second or two, we get the correct answer here, challenge solved. We get the flag, and it says here that the total time that elapsed is 2.178 seconds. From attempt 1, where this IP address had a login failed, and then all of these other login failures, and then finally attempt 15, login success, and it was all within 2.1 seconds. So that is the correct answer. But 200,000 lines, and it literally gives us this answer and does all of that analysis in literally a second. And all in this relatively short script. So that is the power of Python here for these challenges. Okay, so let me go ahead and put that in. There we go. So now the next one, I quite like this one. This one is fun. So the scenic route. With this one, we're given, see here, we're given all of these different geo-coordinates. And if we go down, you can see there's 16,000, not credentials, but 16,141 geo-coordinates here. And we now have to plot them because it tells us in the challenge, or where are we going here? So it tells us here, filter the tracker coordinates to only include points within the UK mainland, and plot the remaining coordinates on a map to reveal a hidden 5-letter word. Technically, it's not a word, so I shouldn't have said that, but it's a 5-letter combination, basically. And there's a few ways we can do this. Okay, so there is a script that I'll show you, but something Uzaya mentioned in his write-up as well is that you could technically just put the entire file into Google My Maps. So I'm going to show that as well. I tried to do that on a different, random website, and it didn't really work. So I thought that with there being so many, those tools kind of failed. But on Google My Maps, that one does actually kind of work. So let's see here. So this is Google My Maps. This is a very cool thing to play around with if you haven't done so already. You can add loads of different points here. I've done it before where I was just for fun in spare time looking at FBI top 10 most wanted fugitives. And you just put points on the map around the areas they were last seen. You could put an eye icon. You could put CCTV cameras with a link to the YouTube feed. You could do literally anything on here and it's free. So it's really cool. But if we go now, so I've added a layer here, and then under this layer, if you import, browse, and I'm going to just import the tracker coordinates. Instantly it collects those by the titles, the headers, and we can continue. Let's just click this. And then you see instantly within a second, it's plotted all of those 16,000 points on the map. So if we zoom in specifically just to the UK, you can see how it's kind of forming those letters. So we can see this top one is a V. We have this, which, potentially looks a bit like a Q, then an X, maybe an R, and then an M. So you can kind of see it here. And to see this even better, if you were to click onto one of these, you can go to the style and basically edit them. And I found one, if you go into more icons, because like I mentioned, if you were doing this for an investigation, you can like change all of the colors. So you could have like a house icon and, maybe change the color, whether it's a family property or a associate's property. You could have the house, but in different colors, all of that kind of stuff. But I found this one, which is a very small dot. And that makes it much easier to see that, yes, this is a V, this is a Q, this is an X, and then we have an R and an M. So that makes it much easier to see. But yeah, it's pretty cool that 16,000, and it literally just plots them all on the map here within a second, and it's all completely free. Okay. But with the Python script version, what you can basically do is, let's see here, let's go into challenge 3, is I've got this one which uses Folium, and then it will use a web browser as well, simply just to bring up the page. So we have the bounding box. So like I said, technically, even though it's not required, what you would do is remove all of the coordinates that are outside of the United Kingdom. So we have the bounding box is basically the minimum latitude and the minimum longitude and the maximum versions of those as well that is within the United Kingdom. So then later on, we can compare each of the coordinates in the list to see if it is within the United Kingdom or not. Then we have a list here. So usually we have the dictionaries, which is the curly brackets, but in this one we have a list, which is in the square brackets. And then let's see, so we have file reading. So this opens up the file of the coordinates, and then it reads through using the CSV that we used previously. It reads that file because, see, this is a CSV. They're just separated by a comma. And then we have it looping through every line in that CSV and getting the latitude and longitude for that particular entry. We then filter it. So we check to see if the latitude and longitude, in this case, if the UK latitude minimum from up here is less than or equal to the latitude that we're currently looking at from our dataset, and if the latitude in our dataset is less than or equal to the UK latitude maximum. Again, it might sound confusing, but it's basically just checking if the current latitude we're looking at is within the kind of boundary of the United Kingdom. And then same thing for the longitude as well. If that does match, and if it is within the United Kingdom, we can then say UK points append, and we add that longitude and latitude to our list of UK coordinates. If not, it just gets ignored and does not get put into this list. And then we have it print out. This was cool, by the way. It's not really relevant to any analysis, but I only learned from these challenges here that you can do this, where you could put like a bit of text, like the equal sign, as an actual string. So it's just it's not treated as a mathematical thing, it's text. But then you can do times 40, and it actually adds 40 of them like in the display. So it's just a cool thing that I learned from this. And then it says data filtered successfully. And then what it's going to do down here is actually draw the map. So using that Folium import that we did, it is going to create a Folium map. it's going to put where the start location is. So it's going to be positioned looking at the UK with a certain amount of zoom. So we're not like loading in the map and seeing the whole world. It will be zoomed into the UK. And then it's going to loop through all of the latitude and longitude in our UK points list. So only the UK ones. It's going to loop through those and basically add a circle marker on each of those points. And then it saves that map as a HTML file. So you can see here, it saves it as solvedmap.html. And then it simply uses the web browser import to open up that file on our device. So it's basically like opening a URL, but it uses the file so that it opens the file instead of opening a URL in our web browser. So if I run this script, you see there, it literally just instantly goes through all of those 16,000 coordinates, calculates which ones are in the UK, cuts out all of the others, and then plots all of these like 1,000 coordinates on the map, and then opens it in our browser. So we can now instantly see the letters that it makes. If I zoom in, you see they are actually individual points. It's just that when you view them out here, it does very clearly show you the letters. So we have V, Q, X, R, and M. So we can now go and put that in here. There we go. So now coming on to the final two, and these last two are connected. With this one, we basically get a zip folder of around 500 images. And I think you can see those here. So these are the 500 images. Obviously, right now they're just colors. As again, I used a Python script to just automatically create all of these, where most of them have no metadata and one of them do have it. But, you know, they're angled from more that, oh, a photographer took these and so on. And the idea is we have to find the one image that still has some intact metadata in this zip folder and extract the 16-character image unique ID. So let's go back to the thing here, challenge 4. And with this one, you can see this is the entire script here, very short. And let me go back here. So what this does is simply import OS, which is one of the operating system things. It allows you to work with like folders which are on your actual operating system. So since all of these photos are within a folder on my system, it allows us to work with that. We then have PIL, so this is like pillows, I think it was called. And with that allows us to work with the imagery and pull out any EXIF, and you can do various different things with this in terms of imagery. So we set what folder we're going to be working with. So I have all of the images in a folder called subject images. We then do a for loop where it is going to grab the file name from all of the files within our folder. So again, you can see it's using the operating system import that we did here to grab every file that was within this folder that we set here. And it's going to loop through every file name. And as it does that, it's going to open every file, not in the traditional sense. It's not going to open it up and allow me to see it, but it's going to open the file within Python, allowing it to then do different actions with it. And so then EXIF data, it's going to pull out any of the EXIF data in that image. It then does an if statement. So it checks if EXIF data existed in that particular image, because again, it's looping through image one by one. If that particular image had any EXIF, then it says metadata found in, and it gives us the file name of the one the EXIF data was found in. If not, it will just move on and keep looping until it finds an image that does have metadata. When it does find the correct one, it will do a for loop, and it will go through those EXIF items, so all of the actual stuff in the EXIF metadata, and it will just print them out. So if I run this, you can see instantly, less than a second, it goes through the 500 images and finds the one which does have metadata, which is image 1191. And it says like software, EXIF Scrub Pro, we have orientation, the artist, and all of this other stuff, including what we were asked to look for, which is the image unique ID. So we can take that unique ID, come back here, and put that in there, and we get that correct. And then that brings us on to the final challenge, where we now are not using Python. So it's a fun little side quest, I suppose, where it asks us to identify the make and model of the camera used to take that photo. So again, this is where I think I said in the previous challenge something about how it's, some new type of photography, because I wanted to make it clear here that you are looking for an actual camera, even though the photos are just colors. So lots of people actually struggled here. And it's another thing where it's funny. It's like, if you know the resources, then it's just really easy. And if you don't know the resource, it can actually be really hard to find that. And if you just aren't aware of that stuff even existing. Because the website you use to get this answer, I've heard of it for years, but rarely find an actual use for it. Because I suppose metadata is a lot more rare, especially even though it totally exists. It's in terms of social media, it all gets stripped out, usually. Not always, but usually. So it's just a bit more rare. But I've heard of this website for years, and I just thought it would be fun to include it. So if we go back, you first had to look at what other metadata you had. So, and by the way, again, working with like the AI to really make a script that could generate all of those images really quickly and put metadata on one of them, it was trying to put only the image ID and then a serial number. And I said, no, I don't want to make it obvious that it's the serial number. Put in more metadata so that they have to actually identify that it's the serial number that will be useful. So things like that. You have to find that the body serial number here is what you need to use. And so if we take this body serial number and we bring that over to stolencamerafinder.com, this is where you're able to search that. So usually, you could drag or drop a photo here and it would automatically pull out that metadata and try to find you imagery taken by the same camera. Usually, I think it's stuff from Flickr. But you can click down here, this small part that says no photo. And then it simply asks you to enter a serial number. So now if you take that serial number that we found and put it in here, search, you then get all of these results for that same serial number. And that gives us the model of the camera, which is this Nikon Z8. So, okay, let's go back. And there we go, we get that one correct. So yeah.